Hello everyone, myself Akshata Bhole. Today in this video we will discuss about electric motors. So what is an electric motor? Electromechanical device that converts electrical energy to mechanical energy is known as electric motor. Mechanical energy used to, for example, rotate pump impeller, fan, blower, drive compressors and lift materials. Motor industries are of 70% of electrical load. Next, principle of how motor works. An electric current is in a magnetic field will experience a force. If the current carrying wire is bent into a loop, then the two sides of the loop which are at right angles to the magnetic field will experience force in opposite direction. The pair of force creates a turning influence or torque to rotate the coil. Practical motors have several loops on an armature to provide a more uniform torque, and the magnetic field is produced by an electromagnetic arrangement called the field coils. Next, the structural design of electric motor. An electric motor is all about magnets and magnetism. A motor uses magnets to create motion. This is the image for structural design of electric motor. Now, classification of motors. Electric motors are classified into two types: alternating current motor, that is AC, and direct current motor, that is DC. Now in AC motors there are two types of motors: synchronous motor and induction motor. And in induction motor there are two motors: single phase motor and three phase motor. In direct current motors, they classified as two types: separately excited and self-excited. In self-excited, there are three types of motor: series motor, compound motor and shunt motor. Now, what are the AC motors? Alternating current, that is AC motors, used an electrical current which reversed its direction at regular intervals. An AC motor has two basic electrical parts, a stator and a rotor. Now, alternating current motors are divided into two parts: synchronous motor and induction motor. In that, induction motor is divided into two parts: single phase motor and three phase motor. Electrical current reverses direction in AC motor. Two parts of the AC motors are stator and the rotor. That is, stator is stationary electrical component and rotor is rotates the motor shaft. Speed difficult to control. There are two types: synchronous motor and induction motor in AC motors. Now, what are the synchronous motors? A synchronous motor is an AC motor which runs at constant speed fixed by frequency of the system. This motor rotates at a synchronous speed which is given by the following equation: Ns equal to 120 F upon P, where F equal to supply frequency and P equal to number of poles. Now second part is induction motors. Induction motors are the most common motors used for various equipments in industries. Components of induction motor is rotor and stator. In rotor there is squirrel cage and wound rotor. Induction motors can be classified into two main groups, that is single phase induction motor and three phase induction motor. In single phase induction motor, these only have one stator winding, operates with a single phase power supply, and three phase induction motors are used three sets of stator coils. The rotating magnetic field drags the rotors around with it. Now DC motors. DC motors, as the name implies, use of direct unidirectional current source of electricity, that is batteries and DC power supply. When power is applied, DC motors turns in one direction at a fixed speed. They are optimized to run at a fixed, usually high RPM. Torque is fine. Torque is highest at the rated speed and lowest at low speeds. Almost all can be reversed. Inexpensive and commonly available. Now, what are the components of the DC motor? First is field pole. In that, north pole and south pole receive electricity to form magnetic field. Second component is armature. Armature cylinder between the poles, electromagnet when current goes through, and link to drive shaft to drive the load. Third component is commutator to overturn current direction in armature. Now the main advantage of DC motor is to speed control without impact power supply quality, that is changing armature voltage and changing field current, and it is suitable for turning and spinning etc. Restricted used few low or medium speed application and clean non-hazardous areas. Now the relationship between speed, field flux and armature voltage. Back electromagnetic force, that is E. It is denoted by E. E equal to K phi n, and torque is denoted by T, that is equal to K phi armature current, where E equal to electromagnetic force developed at armature terminal, phi equal to field flux which is directly proportional to field current, n equal to speed in rpm, T equal to electromagnetic torque, Ia equal to armature current, and K equal to an equation constant. Now the types of the DC motor. Separately excited DC motor, field current supplied from a separate force. It's called the separately excited DC motor. Now self-excited DC motor. In self-excited DC motor, there is shunt motor, series motor and compound motor. So first, shunt motor. The field winding is connected in parallel with the armature winding. It's called shunt motor. Second one is series motor. The field winding is connected in series with the armature winding. It's called series motor. And last one is compound motor. Compound motor is a combination of shunt and series motor. So what is the efficiency of electric motor? The efficiency of a motor can be defined as the ratio of a motor's useful power output to its total power output. Motors converts electrical energy to mechanical energy to serve a certain load. In this process, energy is lost as shown in the figure. The factors that influence efficiencies are age, capacity, speed, type, temperature, rewinding and load. So what is applications? The different types of motors possess different operating characteristics. That heavy industrial application. In heavy industrial application we use AC motors, and in mobile robotics and hobby robots we use DC motor, DC servo motor and stepper motors. Thank you.